In our last episode, we saw how we can integrate our APIs with DynamoDB. So we can go and explore the DynamoDB contents that we created in our last episode. So you can go to services and search for DynamoDB. Click on tables. Select the table that we created as part of our try, that is task-dev. And when you open this, you can see all the information related to this table. That includes the item count, the table size, the capacity metrics, the usage, etc. And at the same time, there is an option called Explore Table Items. On click of it, you will see all the items that are present in our DynamoDB table. If you click on it, you will view all the values, and if you want to see that in a JSON format, you can click on the JSON view option, which will give the data in JSON. You can toggle this off to see it in JSON, and if you toggle this on, you will see it in a DynamoDB JSON format, which will showcase the field name along with the type. So here it is number, string, and string. Okay. So what we will do in this video is we will protect our APIs with Lambda Authorizer. If you notice, all the APIs that we created, that is create task, update task, get task, all of these APIs are open. When I say open, I mean anyone can invoke these APIs without authenticating themselves. This is not ideal. So what we will do is we will work on our first authorizer in this episode. Now, this is the diagram that we saw in our first video, right? So at this moment, we have an API gateway. We have the three functions which are interacting with DynamoDB table. In this episode, we will work on Lambda Authorizer. Now, what is Lambda Authorizer? Now, Lambda Authorizer is just another Lambda function that will be invoked by API gateway before routing the request to the respective functions. So, let's say I want to authenticate the create task API. In order to achieve that, we will create a Lambda function that would return something known as a policy, based on which the API gateway will understand whether to allow or deny that request to that particular API. Okay, so without wasting much time, let's jump into it. So before we start looking into this via the code, let us just go to the API gateway service in AWS. We will select the API that we have built, and if you look into the authorization section and you select any APIs, you see there is no authorizer that is attached. Okay, now there are various options like IAM, Cognito, Lambda Authorizer as such, which we will see in this video. All right, so let's jump onto our VS Code and we will create our first authorizer. Okay, so in order to create our first authorizer, as I mentioned, it is just another Lambda function. Okay, so I will go to SRC and I'll create a folder called authorizers. Okay, within this authorizer, let's call our file name as token authorizer.js. Okay, you can name it anything. So what we will plan to do here is we'll keep it very simple. when we invoke any API, we will pass some kind of a token, let's say user allow, user deny, based on which our authorizers can return the respective policy, whether to allow the user or not to allow the user to invoke that API. Okay. One of those things that you need to take care here is, as we saw, this is just another function, right? So we can have exports dot handler. We will have the same format as we saw last time. Okay. Now, since we will be passing an authorization token through the header, right? What we can do is we can extract it from this event, under which there will be a object called headers. Okay. So what we can do is we can grab that token from event.headers.authorization. Okay. What this means is grab the value from the authorization header that is provided as part of the API. Okay. What we can do is we can console it so that we can see whether the value is received, the token received, and we will use this. Okay. And what we will do is at the same time we will also log the event so that you see what all data we get as part of the event. So I'm just doing a JSON stringify in event. Okay. So as we discussed, we will have couple of values. If the token string is user-allow, we want to allow the user to access the API. If it is user-deny, we want to deny. If there is no token passed at all, we want to reject the request. Okay. So what we will do is we will write if token equal to user allow. Okay. We want to allow. Okay. Else if token is user deny, we want to deny the request. And if there is nothing, we want to reject. So in this case, we can directly pass the first parameter to the callback, and we can say no authorization header or values found, rejecting the request. Okay. Now what should we do here, right? So basically, for the API gateway to understand how to interpret the response, the return type, the return response, right, that we do from this function should be of a particular format. Okay. And the format is basically the policy format that we need to align to. Now what do I mean by policy format? If you go to IAM, okay, and look into policies, okay, expand any policy that you have here. So basically we need to align with this format wherein there is a version, there is a statement, effect, action, and the resource. Now since here we want to invoke an API as part of the validation, the name will be invoke execute API :invoke. So that is what should be the action in case of the policy that we want to create. Okay. So what we will do is we'll go to our code back and let's create a method called generate policy. Okay. Now the general policy need to have something known as principal ID, which is the user that is trying to access, effect, and resource. Okay. So what we will do is we'll create a response object which is empty for now, and within this response we will save this principal ID, and if this effect and resource is provided, we need to generate the policy document. Okay, so we create a variable policy document, and within this we saw there needs to be a version, right? So basically we need to have this. Okay, so we'll copy this. Okay, so we have version, we have statement. Statement is a array, right? And within this array it contains an object. The object should have effect. Okay, and we will use this effect. So this basically generate policy we will call from here. So it will be something like callback, null, we'll call generate policy. The first one is the principal ID, which in this case will be same as the token, right? The second is effect, we want to allow, and we need a resource. So basically this resource should be the ARN of the API or the function that we want to invoke, and that value we will get from this event object as part of route ARN. Okay. Similarly, if for deny, here I will use deny. Okay, so effect is effect, action is, as I mentioned, we should allow to invoke the API. So the action should be execute -API : invoke. Okay, and the resource should be the route ARN value that is passed to this resource. Okay, great. So we have this policy document, we can attach it to response dot policy document equal to policy document. Okay, so this is good. Okay, now let's say in addition to this policy document and principal, let's say you want to pass in some few details related to the users or any attributes, right? Because as part of this flow you could even integrate with database, get some data about the user, etc. If you want to pass this additional data, right, back as part of the successful authentication, what you can do is you can set the response.context, which is an object, and you can pass any additional key value pairs, anything like, let's say powered by, let's say tech with Durgas. Okay, so we will see how this is seen. We can do this. Okay, finally what we will do is we will print the response so that we can see what is the generated policy and the response, and I will do a return response. Okay, so I think this should be all that is needed. Okay, now since we have created this file, we need to register this authorizer in our serverless YAML file. Okay, so the first step is, what we need to do is we need to declare that authorizer within our functions. Okay, so here let's call it token authorizer, and within this we have handler, we have that stored under authorizers slash token authorizer dot handler. Okay, once we have created this under function, we need to register a authorizer. In order to do that, we need to create a authorizer under this provider section. Okay, and that authorizer should be for our HTTP API. So use this key called HTTP API. Within this, you need to have authorizers. Give some logical name. Let's call it token auth. And then we need to define the type would be request, because we want this authorizer at the request scope. So the next field should be the identity source. What this identity source does is it indicates where should we find that token. Okay, for that we indicate that find this token under request dot header dot authorization. Okay, and the last key that you need to provide is function name, and this function name should be the name that we have defined under functions, that is token authorizer. All right, now we have defined our authorizer. Now the last part is just to hook up this authorizer to our three APIs, and that is very simple. So in addition to path and method, just give an option authorizer and give the name of the authorizer that is defined here, right? So what is the name? Token auth. Okay, similarly, let's just copy this in all our three APIs. Great. So once done, let's deploy. In order to deploy, we can give SLS deploy command. Okay, let's wait for this to be deployed. Okay, our changes are deployed. Let us just go into the AWS console and verify that this authorizer is actually created. So what we did here, we defined a function, right, which is a Lambda authorizer. So it should create a Lambda function, and at the same time there should be an authorizer that is defined within our API gateway. So let's go to AWS console. Let's open Lambda, and under Lambda we should see token authorizer. Great. So we have this token authorizer here. So let's just confirm on the API gateway as well. So we go to the API gateway, we open our API, we go to authorization, and if you see now, for all the APIs we see Lambda auth being tagged. This is because we had set this authorizer for all the three APIs that we had. If you click on it, you notice it says that we are using an authorizer, that is token auth, which is of type Lambda, right? And it will invoke this given function for authentication. Okay, so let's go and try out our APIs. So we go back to our api.http file wherein we have all these three API defines. Let's make a call to the get task API. If I invoke, I get unauthorized. This is because we have not provided the token that is needed. So let us go ahead and use the token. So we saw that the token we had to provide as part of the authorization header, and let's use user deny. Okay, even now we are actually providing a token, but this token should not be allowed as part of our implementation, right? What we had implemented is that if the token value equals user-deny, then don't allow the user to invoke this API. So let's execute it. Okay, so we have a problem here. So let's go ahead and debug why we are having an internal server error. So what we will do is we will go and check our CloudWatch logs. Okay, so we go to the CloudWatch logs. The first part is the authentication, right? So we go to log groups, we open the token authorizer, click on the log stream, and we notice here is that this is the console log that we did for our event, right? As part of event, we saw that there are different data that is passed, domain name, prefix, etc. And at the same time, there is this route ARN. If you see, the route ARN is the one ARN for our get task method that we were planning to invoke. If we go down, we see that the token received was user deny. Okay, and if we expand, this was the response that we created, right? Version, statement, API. Okay, this seems good, and we did return. So let's go to the get task and see what is the problem here. Okay, here we see, okay, there is no error at all. All right, so let's go and debug. Okay, so if we look at the response here, one thing is the APIs were working. We just attached the authorizer and then we started getting internal server error, which indicates that there is no problem with our existing method. It is something to do with the authorizer that we have introduced. Okay, so let us look into the response and see if it is aligned with what it should be. Okay, so if we see, we have principal ID, the policy document, which has version, statement, effect, action, and resource. Okay, I think I know the issue. The issue is because the resource R is small. It is case sensitive. So we need to change this to resource with capital R. So what we will do is go to the code and change this to capital R, and we will deploy. Hopefully this should make it work. Okay, we have the functions and the code changes deployed. So let us go back to our client and try this user deny request again. All right, so now we see that we are getting forbidden, which is correct because we have user deny. So let's change this to allow, send this request again, and we do see the response back. Okay, so with this we know that our Lambda Authorizer is in effect. We can try out the other API as well. Let's say we want to create the third task. My third task, do X, Z, Y, whatever, right? So I send the request. I'm getting unauthorized, which is correct because I haven't supplied the token. So if we pass the authorization header and do a send request, it is successful. We can do a get task as well, and now it returns 3. Fantastic. So we do have our Lambda authorizers in place, which is working perfectly. So a quick optimization that we could do, which is not related to the Lambda authorizer, but it is related to the functions that we have deployed. So since we are using a Node.js, right? So Node.js works entirely on the event loop concept. And in order to ensure that it doesn't wait for a long time, and once it is done, it can just return back, right? So that our given function doesn't take a lot of time to complete or doesn't get hanged. What we need to do is we need to supply something known as the callback. We need to provide the callback waits for empty event loop property, and we need to define it as false. In order to do that, what we can do is go to our all the methods, and within this context, within this context, we can set that property to callback to false. Callback waits for empty event loop equal to false. Okay, so this is a good practice. So ensure that if you are using this callback for your return, it's always good to have this property set to false, so that there is no delay because of the event loop concept in Node.js. Okay, we will add it here. Okay, so now the other optimization that we can do here is we are using AWS SDK for interacting with AWS services, right? And this SDK internally makes REST API calls. So what happens is, whenever there is a API call that is established, right? Basically, when two systems talk to each other and they are secure, there is an TLS handshake that needs to happen between these services, and those adds some latency, right? It adds some delay to your final response time. It may not be very huge, but it's in milliseconds, like 60 milliseconds to 100 milliseconds, and we can improve it, right? By indicating the AWS SDK that please reuse the connections and don't try to do a TLS handshake every now and then. So in order to do that, AWS expects environment variable to be passed, which is known as AWS underscore Node.js underscore connection reuse enabled. Okay, so what we will do is we will go to our serverless YAML file, and under the environments, we will set that property to 1, which is enabled. Okay, so it is AWS underscore Node.js underscore connection underscore reuse enabled, and the value should be 1. Okay, so let's deploy this change. Okay, so while these changes are getting deployed, you will not see any difference. Okay, the difference could be hardly in some milliseconds, but you will not be able to see it with your naked eye. Okay, so what we will do is we'll just go to our CloudWatch. Let's just look at few logs. Okay, we'll open the get task logs. Okay, the recent one, and we do see that there is a start and there is this get task invoked where we were printing the entire event body. And if you notice here, under the request context, there is this authorizer Lambda powered by, right? if you notice, this is the additional attribute that we had provided through the Lambda Authorizer along with the policy document. So let's go back and just have a look. So we had this Lambda Authorizer where we had this generate policy. Along with the principal and the policy document, we had also set the context and we had provided these additional fields. These additional fields could be some additional attributes or metadata related to the customers, users, groups, etc., which you are free to add. And the same value can be captured using the event object, and within that event object you can go to the request context under authorizer and get that respective data. Okay, so that's all I wanted to share as part of this video, wherein we have seen Lambda Authorizer. In the next episode, we will see how we can use AWS Cognito to manage our users, and then we will use this Cognito and hook it up to our APIs for validation or for authentication. So I will see you in the next video. Until then, keep learning.